Hi everyone. Today we're going to go through lesson 703 on probability. In today's lesson, we are going to discuss sample space, theoretical and experimental probability, and then compound probability. So first up, let's go over a little bit of vocab. So when we are working with probability, it's kind of another name for chance. So it is the chance that a particular event will occur. So if we think about a coin toss here, if you flip that coin, what's the probability? What's the chance that it's going to land on heads? Well, it'd be a 50-50 chance because half of the coin is head, half is tails. You have a 50-50 chance of it landing on heads versus tails. Then another word you'll hear used today is outcome. Outcome are all of those possible results. So when we go back to our, coin toss here, there are two possible outcomes. It could land on heads or tails. If we look at this picture of the die right here, if it's a six-sided die, we have six possible outcomes because you could roll it and it could land on a 1, 2, 3, 4, 5, or a 6. So the probability, that's our main focus for today. What is the chance that something will happen? And then the outcome is what we're trying to find the probability of. Essentially, it's all of those possibilities, all of those outcomes that we are dealing with. Now, we can talk about probability in a variety of ways. We can use fractions, decimals, percentages, or words to describe our probability. So if we're, talking about the weather, a lot of times, the weathermen will use a percent. They'll say there's an 80% chance of rain. Well, if there's an 80% chance of rain, that's pretty likely that it's going to rain. Or, maybe you're at a sporting event and you have a major underdog. Then you might say, there's, only a 30% chance that this team is going to win. So that would be pretty unlikely. That would, lead to that upset there. So you can use any of these forms to describe your probability. I would say that the fraction form and the percent form are kind of the most common ones, but probability can be expressed in any of these formats. All right, one more set of vocabulary here today before we get into our examples would be sample space. So sample space is a listing of all of our possible outcomes. So if we kind of think about, flipping a coin, our outcomes would be it could either land on a head or a tail. And then when we talk about sample space, that would be us listing, well, heads and tails, because those are all of the outcomes together. So for these examples here, if we check out our die, the sample space would be all of the possible outcomes, all of those options. So it would be the numbers 1, 2, 3, 4, 5, and 6. Now, if we look at this bag of marbles here, I can see that there are blue marbles and red marbles. So blue and red would be my sample space. Those are the two possible outcomes. If we're, picking a flavor of ice cream, and these are the only choices we have, well, our outcomes would be chocolate, vanilla, strawberry. So if we group all of those outcomes together, that's what makes up our sample space, chocolate, vanilla, and strawberry. And then lastly, if we look at this spinner down here, our sample space would be all of those sections. We have red, yellow, blue, and green. That is our sample space. Those are the four possible outcomes and options that we could have. The first type of probability that we're going to discuss today is theoretical probability. This, is what we've kind of been talking about so far with our coin. When we talk about what is it going to land on heads or tails, it's the chances that it's going to land on one thing versus another. It's what we expect to happen. So when we create that probability, most of the time you initially create your probability as a fraction. And then if it's really being asked for it as a percent or as a decimal, you can convert afterwards. So when we set up our probability fraction, it's going to be set up like this, where the numerator, so that top number, is your favorable outcome. It's what are you trying to find the probability of? Then the denominator is essentially your sample space. It's what are the total number of options. So if we look at this example here on the left, we have a bag of marbles. If we want to find the P, and that stands for probability, of the red marbles in this bag, well, I count that I have 1, 2, 3, 4, 5, 6, 7 red marbles. So that's going to be our numerator because we're trying to find the probability. How many chances do we have of picking a red marble? Well, 7 of them are red, so I have 7 opportunities to grab a red one. And then our denominator is the total number of marbles. So we had 7 red plus 8, 9, 10, 11, 12 total marbles. So the probability of us picking a red marble would be 7 out of 12. And then we could do the same for blue. That's what this stands for. P stands for probability. And then in parentheses is what we're trying to find the probability of. What's the probability of us getting a blue marble? Well, 5 of these marbles are blue. That goes in our numerator. There are a total of 12 marbles. That goes in our denominator. A few other, types of experiments that you'll see, whether it's in this video today or whether it was in class or in any of your assignments. A lot of times we can see stuff about, using a deck of cards, what we just did here, pulling marbles from a bag, spinning a spinner, doing a coin toss, rolling a die. These are kind of some common, experiments that we can do when we're working with probability. All right, so let's practice this real time. And we're going to use this by having a deck of cards. Off to the right here, I have a little graphic in case anybody's, not familiar with it, or even if you are, it always helps to have a, picture here. So if we have a standard deck of cards, it contains 52 cards, and there are 4 different types called suits. We have our spades, hearts, diamonds, and clubs. Within each type, so within each suit, there are 13 cards. We can see them listed here. It goes there are 4 of each type, and it can go ace through 10. And then we have our face cards, jacks, queens, and kings. It's split, since we have 2 suits that are red, diamonds and hearts, 2 that are black, spades and clubs, 26 red cards, 26 black cards. So we can refer to all of that when we're answering these questions here. And then we have a reminder up here. When we set up our probability fraction, we can set it up with what we're trying to find the probability of. That's the favorable outcomes in the numerator. And then the total outcomes, that sample space, is our denominator. So for our first question here, it says, what is the probability of drawing hearts? Drawing hearts. So we want to know how many of these cards have hearts on them. Well, we see that hearts is one of the suits, and we're told that there are 13 cards in each suit. So that means there are 13 spades, 13 diamonds, 13 hearts, 13 clubs. Well, I wanted to know how many hearts, so that means there are 13 hearts. That is what we're trying to find the probability of. That's our favorable outcomes. That's going to be our numerator. Then our denominator is the total number of cards. Well, there are 52 cards in that deck. So that's the total number of cards I could choose from. So 13 out of 52 is our probability of us drawing a card that is a heart. All right, let's try this next question. We'll change colors here. What is the probability of drawing a red card? So read it carefully. Always make sure you're finding the right thing. We want to know the probability of a red card. Well, if we look at the notes here, we're reminded that 26 of the cards are red. That's going to be our numerator because 26 is how many red cards we have. And then our denominator is the total number of cards, which is 52. And you could technically simplify this fraction if it doesn't tell you that you need to, just leave it. But if you want to simplify or if the directions tell you to, then of course you would. All right, third question here is formatted a little bit differently. So the first two questions are completely written out sentence form. Sometimes, though, we will write our questions in an abbreviated version. And we saw this earlier, but just to make sure we're on the same page here, this letter P here just stands for probability. So it's just abbreviating instead of writing the full word, just kind of making it a little bit shorter. And then in parentheses is what we're trying to find the probability of. So this is read as what is the P probability of not getting a red card. So this is sometimes where it can be a little tricky. You got to read it carefully, maybe even read it a couple times to make sure you're finding the right thing because we want it to not be red. Well, in the case of cards here, we have red cards and black cards. So if it's not red, then that means we are really wanting the probability of those that aren't red, which would be the spades and the clubs, the black cards. Well, there are 26 cards that are not red out of the total of 52 cards. All right, our last question here is what is the P for probability of getting a royal card? So the royal cards are meaning your jacks, queens, and kings. So if we look at our picture here, it tells us that there are 4 total jacks, 4 total queens, and 4 total kings. And if I want the probability of you getting any royal card, doesn't matter if it's a jack or a queen or a king, just one of those, then that means we're going to add these up because it doesn't matter which one, it could be any of them. So 4 jacks plus 4 queens plus 4 kings, 4 plus 4 is 8, 8 plus 4 is 12. So there are 12 royal cards that we could choose. That's our numerator. And then the total number of options here would be 52 cards. So there's our probability of that. All right, let's take a couple of these here and write the decimal and the percentage version, just to make sure we remember how to do that. Let's do it for the last 2 questions here. So the way that we convert, the way that we change any fraction into a decimal is through division. And you can divide by hand, or you do have permission to use a calculator and you can divide using a calculator. So that's what I'm going to do here, and I will share my screen and show you a calculator so we can do this division. All right, so here we have the Desmos calculator. It's one of my favorite ones. Let's go through the last couple examples we did together and see how in a calculator we can convert those fractions into decimals and percentages. So the first one we had is what is the probability of not getting a red card? Well, our answer to that was as a fraction, 26 over 52. To turn that fraction into a decimal, we simply just need to divide. You can divide by hand, or we can use the calculator, 26 divided by 52. And make sure you type it in properly. It's 26 first, divided by symbol, then 52. And here we have our decimal version, 0 and 5/10. Now, there's a couple different ways that you can turn decimals into percentages. The way that I'm going to focus on is by multiplying by 100. Because if we think about what the word percent means, it means per cent. Well, per is another word for multiply, and then cent is like century, 100 years, or cents. There's 100 cents in a dollar. So cent means 100. So per cent literally means per 100. So we can take this decimal and, oops, click the wrong button here. We can take this decimal and multiply by 100, and now we have the percentage form. So as a fraction, the probability of not getting a red card was 26 out of 52. As a decimal, it's 0 and 5/10. As a percent, it's 50%. All right, let's do one more real quick. That last example we had done was what is the probability of getting a royal card? And we had said that there are 12 out of 52 cards that are royal. So it's okay that our decimal is not perfect. It doesn't terminate. No worries. We can just, estimate it. We can do some rounding here. We simply divide, and that gives us the decimal version. Then we can take that decimal, multiply by 100, and that gives us the percent answer. So the probability of getting a royal card as a fraction was 12 out of 52. The probability of getting a royal card as a decimal is this right here. We could, round it to make it 0 and 23/100. And then our percent version would be 23%. All right, let's do one more page of examples like this, and then we will move on to another type of probability. So once again, we're dealing with theoretical probability. It's what we expect to happen. So now we have a spinner. We want to know for our first question, what is the probability of you landing on an even number? So sometimes you have to do a little bit of work here. You got to look at this and say, all right, if we want the probability of an even number, how many numbers are even? Well, 2 is an even number, 4 is, 6 is, and 8 is. So we have 1, 2, 3, 4 even numbers. That's our numerator, because our numerator is what's favorable, is what we're trying to find the probability of. Then our denominator is the total number of options. So we have a total of 8 numbers. We have 8 sections on this spinner. 4/8 is our probability of landing on an even number. All right, second question. What is the probability of landing on purple? All right, it wants the probability of purple. Well, when I look at this, I have 1, 2 sections of my spinner are purple. It's going to be our numerator, and there are 8 total sections, so that denominator would be 8. You could simplify this fraction if you wanted to make it 1/4. And then you can divide to get the decimal, which would be 0 and 25/100. And then you can multiply by 100 to get the percent, which would be 25%. So all of these are possible ways of answering your question: fraction, decimal, and percent form. All right, third question. What is the P for probability that it is not red? Keyword is not red. Well, when I look at this, I see that there are 1, 2, 3, 4, 5, 6, 7 sections that are not red out of 8 total sections. So our probability as a fraction is 7/8. Last question we have here is, what is the probability that we will get a number less than 9? Well, that's all of them, right? All of these numbers here are less than 9. So 8 of the numbers are less than 9 out of 8 total options. So if we simplify that fraction, it becomes 1. And then as a percent, that would be 100%. So we have a guaranteed chance, that is certain, that we could spin this and get a number that is less than 9. All right, all we've been working on so far has been theoretical probability. That's what's on the right side here in green. It's what we expect to happen. So in this example here, the probability of rolling a 5, well, if we look at a die, only one of those sides has the number 5 on it. So we have a 1 out of 6 possibility of rolling a 5, because 1 out of 6 sides has the number 5 on it. That's our expected, our theoretical probability. On the left here in blue, we have our other type of probability, which is experimental. Well, that happens when we do an actual experiment. So that means we're literally going to roll this die a bunch of times and record how many times it lands on a 5. So the process for experimental probability is very similar. The numerator is still what we're trying to find the probability of. The denominator is still the total. It just may look a little bit different because we're actually performing an experiment. So in this case here, if we rolled our die 1,000 times, that's the total. That's going to be in our denominator here because that's how many times we performed that experiment. Then our numerator is going to be how many times it landed on a 5. And we're being told here it landed on a 5 140 times. So that is our numerator. So experimental probability, our fraction, our answers may be different because it's based on us actually doing it. It's based on that actual experiment. So the main difference to take away from this is theoretical is what should happen. Experimental is what actually ends up happening after we perform that experiment. So let's kind of compare the two here with, the concept of flipping a coin. So if you have a coin here, one side's heads, the other is tails. What is the theoretical probability of flipping a coin and it landing on heads? Well, theoretical is what we expect to happen. So our numerator is what we're looking for the probability of, heads. Well, one side of the coin is a heads, and then there are 2 total sides of the coin. So it's a 1/2 probability, a 50-50 chance of it landing on heads. But let's look at the other side here, this other question. It says you flip a coin 20 times and it lands on heads 8 times. What is the experimental probability of it landing on heads? So this case, it's experimental because we actually did it. We flipped the coin 20 times. So that is going to be our denominator. That's our total because that's how many times we did our experiment. Then our numerator is how many times it landed on heads. And we're told here that it landed on heads 8 times. So 8 out of 20 is the experimental probability of it landing on heads. And if I wanted to simplify this, I could simplify by dividing by 2. That gives me 4/10. I could divide by 2 again, and that gives me 2/5. If you wanted to simplify it, you could. So that's kind of the difference there. You'll get 2 different answers, but it's a similar process of the numerator is what you're finding the probability of. The denominator is your total. All right, now let's do this comparison again just with a spinner. So if we look at this spinner here, we can see it is in 6 different sections. And so if we wanted the theoretical probability of it landing on blue, it would be as a fraction 1 out of 6. We have a 1 out of 6 chance of it landing on blue. And so as a percentage, that would be 16.7%. And then same would be for each one of the colors. We have a 16.7% chance of it landing on each color. But let's do the actual spinning here and see how many times it really occurs so we can discover what our experimental percentage is. And let's go ahead and spin it 5 times. Oh, landed on yellow once. Oh, now it landed on cyan. Oh, now it's on blue. Now it's on green. And now it's on green again. So that one was really close to us, the experiment matching the theoretical, because it started off by just landing on a different color each time, but then come at the end, it landed on green twice. So we can see here that our percentages are different. And so that's what happens with the experiment is it may not be what you had, predicted, but it often is pretty close. There's a reason that those predictions exist. All right, the final type of probability that we are going to discuss today is compound probability. Well, if we think about the word compound, if we just think about what it means, it's, when we combine things, like if we have a compound word, it's like when we put two words and put them together. Well, that's the same thing here for probability. It's if we have two different events occurring or even more, we combine them together. And there's two different types of compound probability. What's pictured here is the more common one. That's what we're going to start with. And that's an and statement. When you want the probability of both of these things happening. So if we want the probability in this case of us landing on a red and rolling a 1, our chances are going to decrease because it's going to be harder to get both of those things to happen simultaneously at the same time. And we can see that our probability, our denominator, got bigger, and it really lessened our chances here. All right, let's do a couple examples together because I know that's always easier to see it when we can walk through it step by step. So when we have an and statement, the way that we find that compound probability is through multiplying, because both events have to occur in order for it to be true. And so we're going to multiply our two probability fractions together to get that answer. So in this example here, a bag contains 20 marbles. 6 marbles are blue, 8 marbles are yellow, 2 marbles are red, and 4 marbles are green. What is the probability of picking a blue and red marble? So because it says the word and right here, that means I need to be able to pick both blue and red in order for this to work. So first, let's just find what the probability is of us getting a blue marble. Well, if I go back and read through this, I see that 6 of the marbles in the bag are blue. That's our numerator. And then the denominator is the total. Well, the bag contained a total of 20 marbles. That is our blue probability. What would then be the probability of picking a red marble? Let's do that one next. Well, if I go back and read this again, I can see 2 marbles are red, and then we still have the same total, 20 total marbles. So if I want to find this combined of me being able to pick both a blue and red out at the exact same time, we're going to multiply our two fractions together. If you would like to simplify them, you can. I'll do it that way in a moment. But no matter what, you'll get the same answer. Remember that when you multiply fractions, you just multiply straight across. So 6 times 2 is 12. 20 times 20 is 400. Now you can simplify this fraction. First thing I noticed is they're both even numbers, so I could divide by 2. That would give us 6 over 200. Still both even numbers. I'm going to divide by 2 again. That gives me 3 over 100. And then I have nothing else other than 1 that they could both be divisible by. There's my simplified fraction. If you had initially simplified, let's go back up to our blue one here. We could simplify that to be 3 over 10. Our probability of our red one could be simplified to be 1 over 10. And then now if we multiply the simplified version of our fraction, we still get that same answer. So it doesn't really matter if you simplify at the beginning or the end, you'll still get the same answer. But that's a pretty low chance. I mean, if we have a bag of 20 marbles and I'm saying, what's the probability of me picking blue and red at the same time? It kind of makes sense that we would multiply, and our chances, our denominator chances, because it's a fraction, would get smaller and smaller because Not a whole lot of odds in our favor there. Let's try another one here. So what is the probability of picking a pink marble and rolling an even number? Write your answer as a fraction, decimal, and percent. So first, I notice that it says the word and. So that means I need the probability of both of these things happening. So I am going to have to multiply my two probability fractions together to get my final answer. So first off, I want the probability of picking a pink marble. Any of those marbles are pink. Don't worry, your computer's not messed up. It's 0. We only have purple and green marbles. So we have a 0 out of, let's see, how many marbles are there? 1, 2, 3, 4, 5, 6, 7, 8. So a 0 out of 8 chance of us picking a pink marble. Now we want to, and then we want to know what the probability is of us rolling an even number. Well, this looks like a standard die, so that means we have the numbers 1 through 6. Write them out if you have to. We want the chances of us getting an even number. Well, 2 is even, 4 is even, and 3 is even. So 3 of the numbers are even, a total of 6 numbers. Now that I have the probability of each event, we're going to multiply them together. When we multiply this fraction, 0 times 3 is 0. 8 times 6 is 24. And then if we have 0 pieces out of 24, that simplifies to just be 0. And then there's not really a decimal version of 0. It literally is just 0. But I mean, if you wanted to, I guess you could put 0.0. And then the fraction, and then the percent version, sorry, would be 0%. So it is impossible here for us to get a pink marble and roll an even number. We could roll an even number, but we can't do that simultaneously with a pink marble. Not possible. Let's get to our second type of compound probability. When the word says or, that is when we're going to add them together. Because if we think about it, if it's saying you can have one or the other, that actually increases your chances. Because we are going back to our first example here of this bag of marbles. And I'm going to skip ahead in my reading. And if it says we want the probability of picking a blue or a red marble, that means it doesn't matter which. It could be blue or it could be red. So when that happens, we add our fractions together because we are now increasing our likelihood of getting them because it could be either or. It doesn't have to be both at the same time. But the process is still very similar where you can just find the probability of each and then combine it, add it together. So the probability of us getting a blue marble, there are 6 marbles that are blue, 20 total marbles. Then the probability of us getting a red marble, 2 are red, 20 total marbles. So if we combine these and find the probability of us getting blue or red, because it could be one or the other, then we simply just need to add our two fractions together here, and that gives us a probability of 8/20, because there are 8 marbles that fit the category of being blue or red. All right, last example here. Let's do this one as the or version so we can kind of see the difference. So if we want to know this time the probability of getting a pink marble or rolling an even number. So this time they both don't have to happen. It can just be one or the other. Well, our probability of rolling a pink marble hasn't changed. None of them are pink. So 0 out of 8 are pink. And then our chances of rolling an even number are still 3 out of 6. Now, because it's one or the other, we need to add these. Because this one's a little special where the first one is 0, there is a little shortcut that you could take to figure this out. You guys maybe have already done it in your head saying, well, there's 0 chance of that, so it's still just going to be 3/6. But I'm going to treat this like that isn't the case, so that way you would know what would happen if you got to one like this. Because remember that when you're adding fractions, the denominators have to be the same. So I need to make the denominators the same first, then we can add the fractions. Before I do that though, actually, I want to simplify my fraction because it's always easier when they're simplified to work with them. So I'm going to simplify this to make it 0/8 plus 1/2 because 3/6 can be simplified to be 1/2. Now that we've done this, our denominators need to be the same. So I look at this and I say, well, I can take 2 and multiply that by 4 and it'll give me an 8. So then I'll have like denominators and I can add. So we'd have 0/8 plus 4 times 1 is 4. 4 times 2 is 8. Now that the denominators are the same, we can add and we get 4/8, which does simplify to 1/2. So if you watch that and you're like, Mrs. Ailstock, why'd you do that? Yes, I know that because the first one's 0, we didn't really have to do all this, but I wanted to show you in case you had a scenario where it wasn't the case and just remind you that if you're adding fractions, the denominators must be the same in order for you to add. All right. Well, I hope that this video helped you understand probability a little bit better. And, as a little wrap up here, some key differences. Remember that theoretical is what you expect to happen. Experimental is when you actually do it. It's what really happens. Then for compound probability, if it's an and statement, because it is and both of them have to happen, you multiply your fractions. If it's an or statement, it could be either one, and therefore you add your fractions together instead. All right, please make sure to reach out if you have any questions. Otherwise, I hope you have a great rest of your day. Bye.